Okay, welcome to the Wrocław Jug. I'm really happy that you all came here today. Today our guest is Nicolas Frankel. We are happy that you agreed to our invitation. Thank you for coming. Everyone who watched this stream, you can win Intelligent JetBrains license, but to have a chance to do so, you have to be active on the YouTube chat, and it's good to register to our meetup event because then I can write to you. During presentation, you can ask questions, and I will interrupt Nicola and ask those questions to you. And I hope you will enjoy that. Nicola, stage is yours.
Thanks a lot. Thanks everybody to be here. Thanks Sebastian to have invited me. So I welcome you to this talk about change data capture use case. I'm Nicolas Frankel. Now it starts very bad. Now, oh, whoa. It will be bad for that. So what I will propose to do is I will stream from another browser because I know that otherwise it will be really bad for all the presentations. So sorry about that. I forgot that Firefox is not StreamYard friendly. So I will join from another place and I hope that it will work. And I'm again very sorry about that. Two seconds, please. Of course, I must do it at the last moment.
Okay, you have to unmute yourself.
Yes.
Okay, so 2 seconds.
So now I'm unmuted myself. Sorry, I need to share my screen. I don't have the permissions to do it. I'm following the steps. I go to screen recording. I'm really sorry about that. That's not the first time I see that. Fortunately here, I was able to see it much earlier than before. File and folder screen recording, privacy. So I need to get to privacy. And now I get to screen. And I don't have it, otherwise it would be too easy. Screen recording, yes. Now I lock, I use the password. And yes. And normally here now it should let me share the screen. Yes, amazing.
Yeah, everything works.
Yeah, again, really sorry about that. Well, that's the fun of doing live streaming. Now let me get back to my presentation. And yes, So I'm Nicolas Frankel. I've been a former developer, which doesn't help me sharing my screen. I've also held other technical roles, and right now I'm a developer advocate. I also happen to have a cat that is bothering me, so you can sit because now you can understand why I'm not so focused anymore. So this cat is scratching my legs when I'm talking, and of course it's a bit hard to get my train of thought in order. Now he will be gone because he's a nice cat, and I can continue my talk. And I'm interested in change data capture in particular and data streaming in general. I work for a company called Hazelcast. Hazelcast has two products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. The most used one is the map, and the idea is you can have a map that is not only inside your JVM, but it gets replicated or sharded over several other JVM in the network. The other is Hazelcast Jet, and it leverages Hazelcast INDG to do in-memory stream processing, also distributed. And you will see that we will be using both in this talk, but they are not the main focus of this talk. So this our agenda for today is first to think, why do we cache? Because yeah, it's not by default. We should always think about why we do stuff. And then there are some alternatives to keep the cache, which actually is derived data in sync with the source of truth. And one of those alternatives is actually change data capture. It's pretty popular right now. And in the JVM world, we have Debezium, which is a CDC implementation. And I can tell you a bit about Hazelcast and Debezium, how they work together. And finally, I will conclude with a demo, because otherwise it will just be like not very interesting. Theory is good, but my code is even better. First thing first, and yes, it's if you need to remember something from this talk, is this one, is when you add caching capability to your application, you are making a trade-off. And the trade-off is now you have either improved performance of availability, depending whether the network is working or not. But on the other side, you've got data that is no stale. It's not the correct data that you have. It's data that might be up to date, but not might be up to date. And if we take this use case, so this is a pretty simple use case, and I believe that you probably have already implemented or designed this type of application. So you have your source of truth, and the data is in the database, probably a relational database. And then you have your application, and the application reads and actually writes the data through a cache. So the good thing is that, well, since it reads and writes the data, the cache is always in sync with the source of truth. The cache is just a proxy and just like acts as a facade when there is a write or when there is a read. But oh, sorry, I was a bit too fast. But in fact, not many applications are actually run like that. There is always something that writes into our database. And this something might be a web service, might be anything, because our application is, in general, is not self-contained. We need data from outside our app. It might be a reference table, like might be customer references, might be item references if you are doing e-commerce. It might be the list of countries, because yeah, the list of countries, it changes from time to time. But there is something that changes the database. And the problem is if you have cached everything, you believe you have everything here, so the cache doesn't need to read from the database anymore, and your cache is not in sync with the source of truth. So that's a real pretty strong argument against using caches. We don't have the correct data. There is always a trade-off. Some cases it's okay, in some other cases it's not okay. And so the questions that we need to solve is how to keep the cache in sync with the database. And you might have heard this stupid joke that they do two hard things in computer science, naming things, cache invalidation, and of course, off-by-one errors. So which makes it 3. So in a room, the joke is much better. Of course, remote, it's not that good, but still, it doesn't prevent me from trying. Not too hard, but trying. Which brings me to this notion of cache invalidation. And I will first try to define the semantics between cache invalidation and cache eviction. There are two different things which with separate concerns, and we need to make it clear what is one and what is the other. So the first thing is when you try, sorry, my cat again, when you try to implement your own cache, in general, you use a hash map, which gets the job done. I'm guilty of that. I used a hash map for caching before. But we forget the problem that a hash map is not bounded. It can grow like unlimited. You can put stuff and put stuff and put more stuff, it will grow, which depending on your use case, you might encounter out of memory errors because of that. So the idea is, in a professional caching solution, which might be Hazelcast, which might not be, there is a cap size. At least you can set a cap size if you want. And so when the size is reached, you will probably want to put one more entity. And the question is, which entity do you remove? That's cache eviction. And in general, there is a pluggable policy. There might be a default policy, might be not. There are different pluggable policy. The first one might be least recently used. There might be least frequently used. You might have additional priority. So you might put more or less priority on some items, this kind of stuff. That's cache eviction. And then there is another one, which is cache invalidation. And this is linked to the concept of time to live. And time to live is when you put an entity in the cache, you're actually, in general, telling how long you want this entity to be kept in the cache. And in the background, there is a background thread that will check this time to live. And once the time has expired, we'll remove the entity altogether from the cache. And the real problem is to choose the correct time to live. Imagine that we have a time to live of 1 hour and we have a time to live of 2 hours. That means that during 1 hour, we will miss updates. Not great. On the opposite, if we have frequency of 1 hour, that's data changes every 1 hour, but we have a time to live of 30 minutes, that means that we will try to refresh twice more than necessary, and we are wasting resources. So choosing the correct time to live is very important. You can tell me, hey, but it's easy. You know the update frequency. Yes, more or less, but in general, even if you are batching, it won't be the exact time that you choose the frequency to run on. And so you might say, okay, but then we have a polling process. So it's not the time to live of the caching solution. We have an external process. It's the same problem. It's very hard to be very to sync the synchronization of the cache, the time to live, with the frequency of the batch. And it's even more so than most of the time. It might not be batch that is run at regular periods. It might be completely, I wouldn't say random, but it's not regular. So the idea in that case is to say, okay, we cannot have a very precise way to do that, so we will just be event-driven. And the idea is to say if no writes happen, so if the database state is not changed, we don't update the cache. But as soon as there is a write, we update the cache. And even better, we just update the items, the entities that were updated. That would be really, really good. So how do we achieve this? Well, if I tell you about event-driven and databases, the most experienced among you, and perhaps also some juniors, might think about, hey, let's implement triggers. Yes, that's a pretty good idea. But let's not forget that not all databases, they implement triggers. And in general, well, not in general, but in all cases, a trigger is made to update something else from the database. So it might be like a view to a state, or a view to a table, or a table to another table, or something else. But the idea here is we need to call an external process from the trigger. We need to call the caching provider API. And so how do we achieve that? So I checked a bit, because I also was interested. I never implemented it, but I checked. And so let's use MySQL. And MySQL lets you have triggers. And it lets you have something called user-defined function. So the idea is that the function must be written in C++. I don't know about you, I'm a Java developer. I might write some Kotlin, I love Kotlin, but my C++ days, they are like more than 20 years old. I never wrote C++ professionally, and I don't have so fond memory of C++. But let's suppose you are a C++ guru, you are willing to do that, okay? Then there is an additional constraint, is the operating system must support dynamic loading of libraries, which is not super great if you want to be secure. And then this function becomes part of the running server and is bound by all the constraints. And you've got a couple more, but slightly less, let's say, strong constraint, but it's not super fun. Fortunately, somebody did that for us. So it created such a function that is generic enough, and it's on GitHub. I didn't check the last time it was updated, but let's say I believe it can work. And you bind it, you load it into your system, and now you can run this function which it calls sysexec, and then you can call external processes, and it's done. That's fine. But I've been an architect, and well, it gets me thinking. The first problem is it's implementation dependent, meaning that yes, it works for MySQL and only for MySQL. The other problem is it seems to me that, I feel it might be fragile. Something bad is bound to happen. And when that happens, because it's not if, it's when, who will debug it? Will it be a developer? Will it be a DevOps, whatever DevOps means in your organization? Will it be the database administrator? That's a real problem in companies, that there is no clear responsibility. Who will debug that? And it's not only about debugging when the shit hits the fan, it will be about maintaining this, because at some point there will probably be somebody who says, oh, I want to change it. And if you have implemented triggers, or if you are a database administrator, you might know that if you call triggers too frequently, it's really a very resource consuming. And now comes data capture, and I assume that you probably have heard it before. And the idea behind change data capture is exactly that, to track data that has been changed on the database side, and so it can be used to be sent further, or to be transformed, or to be used however you want. And if we look at Wikipedia, that's very funny, because Wikipedia says that some implementation of change data capture is actually polling, like we did before. I told you that it's not super great. For Wikipedia, at least for the authors, that polling plus, depending on timestamp rows or version rows or status rows, are already some change data capture. Triggers are also considered change data capture. But the current way to do this kind of stuff is log scanners. So let's talk a bit about log scanners. There is a very interesting article from Martin Kleppmann. If you don't know Martin Kleppmann, he has written a book about designing perfect data-intensive application. It's really good book. You can probably read it many times. I read it only once, and every time you learn something new. It's really rich and very interesting. He also has written a post about turning the database inside out. And the easy idea, how he talks about it, is like when you use a database, you're actually happy about using the SQL abstraction. And when I mean database here, I mean SQL database. So we are using the SQL abstraction, and we don't really care about the infrastructure. Most, if not all, SQL databases, like the real SQL databases, not the NoSQL that accept SQL commands, the real SQL databases, they are only like one leader and perhaps like passive follower. Like in case the leader fails, then the followers can take the lead. But those databases, they were designed at the time where scalability was not a main concern. So they don't scale horizontally. So there is one leader and follower. There might be other reasons for followers. It might be for performance reasons. So the leader takes all the rights, and many followers, other followers, might like accept the reads. It might also be for failover reasons. But in both cases, it's just one leader. And how do the followers keep up with the change of the leader? That's a very good question, both for the performance use case or for the failover use case. We need a way for the leader and the follower to be in the same state. Or let's say, to be more precise and to be more technically correct, that the follower should replicate the state of the leader in the slightest time frame possible. And we don't care about that as users. We are just using it, and the rest is just an implementation detail. Probably you have a DevOps person or you have a database administrator that takes care of that. So this is implemented through a log file. And as I mentioned, this log file is for data recovery, for failover, or for replication purpose. So every time there is a write, an update, or a delete that the leader receives, the first thing it does, it will write it into such a log file, which is an append-only log file. Then it keeps a cursor. And the follower also keeps a cursor. So if the leader fails, as long as this append-only log file has been written, it can restart where it fell from. And it's the same with the follower. Like it has been written like 5 lines, the follower will read those 5 lines, but put the cursor at the 5 lines afterwards, then there will be another read, and then the follower can read those lines and just like progress the cursor forward. And this is exactly what this log contains. It contains update events, changes to the table or the table data. It can be anything. And so the idea is, okay, what if we hacked the log? Here, for example, I have a sample MySQL bin log. And in this MySQL bin log, you can already recognize some of the SQL. Like here, I have an update, here I have a where, here I have a set. Then there is a lot of stuff that, I cannot understand. Probably a MySQL expert would be able to explain to you a lot of stuff about it, but even then, I'm not sure that this thing would make much sense for him. So it's like the Rosetta Stone. You have something that is very hard to understand. So imagine we can decide that we will be spending a lot of time to understand it, and then we can hack the bin log and provide CDC. But I'm super lazy. And also, again, the same questions that I asked before, it's implementation dependent, it's fragile, and we will maintain debug it. They are all the same, and they are not answered. So the idea is, okay, let's not do that by ourselves. The idea is, hey, let's call Debezium to the rescue. And Debezium does exactly that. So it provides a Java-based abstraction layer for CDC. So it provides you with a unified API, and you don't care whether in the backend it's MySQL or Postgres or whatever. And it's provided by Red Hat. It's open source under the Apache 2 license. Now there is a slight issue. It's very skewed, if not only directed toward Kafka. The idea is that you have your Kafka cluster and you have those like connectors. So you configure them. And now every time there is a change in the database, then there will be an event sent, or I should say like, there will be something that checks that the file has been modified, the log file, and then depending on the configuration, it will create item in the topics that you configured. It might be multiple topics. You can have like multiple connectors writing into the same topic. That's not relevant. Everything is skewed toward Kafka, which again, if you are a Kafka user, is very, very good. But not everything is meant to be put into Kafka. The idea is Debezium provides you with the API, and right now there are a couple of plugins that are already production ready. So there is MySQL, Postgres, and Microsoft SQL Server. There is also MongoDB in case you still want to have NoSQL Server. And there are a couple of plugins incubating. Of course, nothing prevents you from writing your own, and I mean, you can release it under an open source license, and the community will be very happy. So the idea is, for the cache, it's not a great idea to put stuff into Kafka. I mean, Kafka means you store on disk. And the idea of the cache is you put everything in memory, so it's accessible very, very fast. So putting, like storing and writing to disk into Kafka and then reading again doesn't make any sense. So the idea is to use something called an in-memory stream processing engine. And in that case, I will use Jet. Jet is distributed, is also provided under an Apache 2 license, and there is also a Jet Enterprise offering, of course. But I won't talk about it today, so everything will be completely open source. This is a typical stream processing engine. Here, of course, it's Jet, but most stream processing engine provides the same. You have a data source and you have a data sink. And in the middle, you can ingest it, you can combine multiple data streams, you can enrich. That's something that is very interesting, that it allows you to like preload data into memory. So you don't need every time you want additional data to go to the database and to make a query, which takes time, blah, blah, blah. You just read it from memory. And by default, if you have multiple nodes, is distributed, and you can say that some operations, of course, they cannot be distributed, but by default, everything is distributed. There are two deployment modes for Jet. As a Java developer, I assume that the first one is the easiest one. In that case, Jet is just a dependency. You add it to your application. And when you start your application, you also create a new node using jet.newJet instance. And then by default, it will use an auto-discovery mechanism. It will try to find other nodes, and then they will form a cluster. Now, it's very good, but it has some downsides. The first downside is that, well, if you want to scale, and probably at some point you will need to scale, you need to scale either from an application point of view or from a Jet point of view, but then it probably will be from a Jet point of view. But then you will needlessly scale your application as well. And the other problem is if you want to fine-tune your JVM, then in that case, it's hard because you don't know for which use case you will fine-tune it, for Jet or for your Java application. So in general, after some time, it's probably a good idea to move to a client-server model. And the client-server model has dedicated Jet nodes, and in that case, you can use a command line, which of course might not be that great. You can use Docker images. We have a Helm chart for Kubernetes, whatever rocks your boat. And then you only have the client API in your application. Now, on the good side, there is an additional benefit. in that case, you don't need to use Java. We have several bindings. For example, we have C#, we have C++, we have Go, we have Node.js, and we have Python. Today, we released our new version of the Python client. And you have generally two concepts in stream processing engine. Here, I'm using the semantics of JET. You have the pipeline. The pipeline is the code that you declare, and it looks like declarative because you will say, sorry, I read from that source, and I will use this function to transform objects into those objects, and I will filter out this kind of object, and I will write down into this sink. And then when you have written your code, you write a bit more code, but it's not always necessary. Then you submit this pipeline to the stream processing engine. So you are sending code, or at least you make it so. And once the cluster has received the pipeline, then it runs it and it becomes a job. And the stream processing engine is responsible to execute the codes and to distribute the flow all over the nodes and to do its magic. Now we can get back to our use case, because I guess you know where I'm coming from. What I will be doing, I will keep the same application as before, the same architecture. What I will just do is add an additional Jet job that will run into a cluster of one node, because it's just a stupid demo. And this Jet job task is to read from the bin log, and every time there is a change, it will forward those changes to the cache. And now the application doesn't need to worry about the cache being out of sync. The cache will always be in sync. So now it's time for some code, because I've talked a lot. Perhaps there are some questions. Are there some questions? It's time for some questions before I go into the demo. If there is no question, I will drink a bit and I will continue. No questions? No questions. Okay. Now I worry a bit, because on my YouTube channel, I see that I am frozen. So I hope that you can still see me. Otherwise, I will feel very, very bad. Anyway, let's pretend that you can see me, because I cannot do anything. So here I've created an application, and this application actually is a very simple application. It's not complicated. It's a Spring Boot application, and I will be using the Git plugin to create Docker containers because I'm lazy, but that's something else. And I will have a web layer, and I will have family for the pages, and I will get the data from Spring Starter Data JDBC. I'm running here, I will be running H2, but when I deploy it, I will be running MySQL. And of course, I will be using Hazelcast. So now the idea is I have the person controller here. Well, perhaps I will show you directly how it works. I have the demo application, and here I will start it. I have it here. So this is how it looks like. I already pre-populated data because I'm using the Spring Boot starter. So it reads the data.sql file. So I already have something. So here I have John and Jane and John again. And I can decide to say, oh, look here, I have Robert, and it does a refresh. So it refreshes every entity, but because all the other entities, they are already in the cache, it's very fast. And the person repository looks like the following. So I've tried to implement the query cache from Hibernate. and I have an entity cache. And when I do a find all, what I'm doing, I'm selecting everything from person, and this is my query. And in the query cache, I try to see if there is an entry where this query is the key. If there is, then I get the results, and this is a list of all primary keys that I've stored before. And if I do, then if it's not null, then I get it. So I have a message from Twitter. Sorry, I need to check. Perhaps Sebastian is telling me that something is wrong. I muted sound. No, I didn't mute sound. Then
okay. Yes. Do you hear me?
I hear you.
Great, amazing. So there is one question from Josh. How does it glue in clouds? Any semi or full management solutions? It's about your previously talking about.
Not yet, not that I know of. So unfortunately, not that I know of. But I can show you how it works, and you can probably provide your own. That will be pretty easy.
And it's only this question.
Sorry? Okay.
It's only this question. No more.
Okay, great. So as I mentioned, I have the query cache. So first I look if the query is already in the query cache. The value of the query cache is the list of IDs, person ID, and then I get them from the entity cache. And in the entity cache, the key is the ID, and the value is actually the person. Now, when I do my find all, as I mentioned, I will check if there is something in the query cache. If there is nothing in the query cache, then I will actually query the database. And then I do my usual, hey, I will get my result set and my row num. I create the person. For each person, I put them in the entity cache, and I put the query in the query cache. Of course, here I have a single query, but let's imagine that you might have multiple queries. That would be exactly the same. When I save a person, what I'm doing is I'm just putting this entity in the entity cache, and then I update it. It's not transactional. I mean, I didn't bother too much, but you understood the gist. And when I do a get, when I do an update, I redirect to the refresh all stuff. So I reload everything, but in general, well, in this case, everything is already in the cache. So let's try it now on a deployed environment. So I've created this Docker Compose file, and this is not important. Now I have my application. As I mentioned, I'm using Jib to create the container, so I don't need to create a Docker file. And I've added some additional environment variables. Yes, root, not good. But yeah, this is a demo. Here is the pipeline. I will show you the pipeline afterwards. And here is a MySQL database. So right now, what I will be doing, I will be like upping the Docker Compose file, Docker Compose up. And what I will be doing, I will be stopping the pipeline because I want to show you the problems that you have. So I perhaps didn't highlight it enough. So I will wait until everything has started, tells me, hey, everything is fine, pipeline starts, but I want it to stop cleanly. So I will just wait until it has finished loading. Yes. So now I will be Docker Compose stop the pipeline. Stop the pipeline. Pipeline has stopped. Okay, now I start. The application has started, so I reload it here with my data that is deployed, and I do the same. I do Robert, so it stores it into the MySQL, it refreshes, everything is fine. Now what I want to do is I want to change the data without the cache. So I have another application that is called update application. Is actually a Spring Shell application. And I run this application and it allows me to do two things. It allows me, so here, if you don't know Spring Shell, you can type help and you can see that I have two additional commands. So I can list all entities. So normally it should be Robert, Jane, and John, which is what I wanted. It also allows me to update something directly in the database. So I will update the first row so that the first name is Nicolas. Or Nicolas, because yeah, my name is French, so it's Nicolas. And now if I refresh, of course, it reads from the cache, and the cache has not been refreshed. So that's the problem I highlighted in my first slides. Now I will start the pipeline with Jet, and while it starts, I will show you how it looks like. So it's completely separated. If you are working in the legacy environments, you can like deploy it and as a completely separated process. So here I have this update cache job. And how does it look like? Well, I have this main stuff. So this is my entry point. And here I wait for MySQL because sometimes MySQL takes a bit of long to start. And I start this new job. So the here is the one that is interesting to us. What does it do? Well, it gets some data from the environment, of course. We create the pipeline itself. This is Jet specific stuff. And we get data. We say that our source, our stream source, is CDC, is change data capture. This basically is all configuration. So I isolated everything into a dedicated method because it's just configuration. We say, hey, where will be reading from? What is the password? What is the login? The schema, everything. And then the important bit is this one. We say that we will receive records, and we know how to transform a record, which basically is something from Jet, into a person. And now we also write a function that knows how to transform a person into a map entry. In that case, I want the map entry. I want the key of the map entry to be the person's ID. And now it reads like full English. You read from source without the timestamps. Here I don't need no order. I don't care. I will write it down in the log because I want to show you how it works. And then I map the results that I read from Jet to a person and then to a map entry, and I write to the cache. And likewise, the cache is just configuration. You say, hey, okay, I will be connecting to this existing Hazelcast instance, and I want to update the map that is called entities. Now, here lies the trick. I will just go to my application, and I will just refresh. And at this point, when I refresh, you will see that Jet was able to read the log file that was written before it started and to propagate the changes to the cache. And now, every change we might do behind the scene, so here, it will be called. So update to, let's say, Chiara. And so now every time there is a change, the application doesn't care. It reads from the cache, but the cache is always in sync. So it's an evergreen cache. So as a recap, in this talk, again, I've told you about the caching trade-off. Caching is not magical. You get the data either faster or you have more guarantee to get the data, but it might be stale. Depending on your use case, might be good, might be not so good. If you want the data, or let's say, if you want the time where the data is stale to be as small as possible, you need to think about event-driven architecture. And in that case, you can leverage change data capture through Hazelcast Jet to benefit from an evergreen cache. So I hope you like the talk. Here are a couple of references. Of course, you can read my blog. You can follow me on Twitter. It's always nice. I can show it to my blog, to my boss. Here, there is the documentation of Jet about change data capture. If you want to redo the demo that I have done, today I didn't have any failure, which is good. But if you want to be sure that I didn't trick you anyway, everything is on GitHub. And of course, if you're interested in Hazelcast and or Hazelcast Jet, you can join our Slack. And perhaps now there are questions.
No, there are no questions on the chat. You are welcome to ask questions. I will thank you all for coming here. Thank you for write something on the chat. Thank you, Nicola, for giving this talk. I hope maybe someday you will be in the Wrocław and you will give a talk in the person on the Jug Wrocław. That would be great. That would be amazing. And if there is no more questions, thank you again and see you next time.
Thanks, folks. And yeah, I know Wrocław about the dwarfs, so I've taken some pictures already of dwarfs in Wrocław. So I hope the next time I will complete my collection.
We have a lot of them, so you can come here freely. Okay, so
I will be happy to.
Thank you.
Thanks
Bye.
again for the invite, and everybody have a good evening and take care.